Pre-algebra lesson 14, fractions, expanding and reducing fractions. So if you remember from Math 76, a lot of algebra and pre-algebra is very dependent on the fact that you can rewrite the exact same number multiple different ways and make it look very, very different, even though it is in fact the same value. That's something we're going to be doing today as we expand and reduce our fractions. Hopefully I've had time to do this in class. I'm not going to do a visual for this video. What I'm going to focus on this video is how to properly do this. So let's start with some example problems that you will see in your textbook. Maybe I'll start with the second one first. Yeah, we'll start with the second one, and then I will move on to the... I'll probably hopscotch around the page, depending on how I feel. So let's start with the second example problem. This problem says I need to expand the fraction 3/4 so that the denominator is 24. A lot of times when you see the word expand in your textbooks, what they actually mean is multiply. And that is the case here. So what they're asking for is this problem. We have the number 3/4, and they want to know what it would equal if we change the denominator to 24. Now, when I write the problem this way, it probably looks very familiar, especially to those of you who've taken Saxon. You think, oh, I've solved these problems before, but it's a little bit different when we see it in word form. So once we can properly identify the problem, which is I want to take this number and rewrite it with a 24 on the bottom, it should be pretty simple to see what we need to do. What we need to do is ask ourselves, what number can I multiply 4 by that would equal 24? So then it becomes like a missing number problem. Or we could ask, how many times will 4 go into 24? If you know your times tables, you would have memorized that the answer is 6. If you don't know your times tables, you can quickly divide 24 by 4 to get the value of 6. Either way, I see I have to multiply 4 by 6. Now, what we have here is a scale. If 4 gets multiplied by 6 to get 24, then 3 must also get multiplied by 6 to get our answer. So when I do 3 times 6, I get 18. Now, is my final answer only going to be 18? No, I need to write the entire fraction. So the final answer is going to be 18 over 24. Right? And that's how I'm going to write my final answer. Some of you may be asking, hey, Mr. Claiborne, shouldn't we reduce it? Well, fun fact, if you reduce this number, you end up with 3/4. So, and that's also not what they're asking for. They want you to write it with 24 as the denominator. If I reduce it, would 24 still be the denominator? No, it wouldn't. So that's how we expand fractions to change the denominator. Now, let's look at this top one here. Here they ask us to write each number with with a denominator of 20. So some of you may be thinking, hey, this number 5, it's not a fraction. Well, who can tell me how to turn a whole number into a fraction? That's right, we just write it over 1. So if I take the number 5 and I write it over 1, ta-da, it is now a fraction. And then I need to rewrite it with a denominator of 20. So 5 over 1 is going to equal something over 20. And it's very clear to see that 1 must multiply by 20 to become 20. So we'll go to blue now. If I do 1 times 20, that would equal 20. And on the top, I would have to put 5 times 20. 5 times 20. Ooh, let's go ahead and do this one, just in case we're having a tough day and we can't think of it in our head. 5 times 0 is 0. 5 times 2 is 10. 100. So 5 times 20 equals 100. So the answer to A would be 100 over 20. Now for B, same thing. I have to make this equal something over 20. I guess we'll do the reverse over here. We'll go blue and red. So if I have 3/5, I have to ask myself 5 times what equals 20? Let's see here. Maybe I'll count by 5s. 5, 10, 15, 20, 4. Okay, so 4 5s. So 5 times 4 equals 20. That means I take 3 times 4 and I get 12 over 20 for my answer. So B would be equal to 12 over 20. And these would both be our final answers. All right? So there, we've learned how to rewrite denominators. Or expand fractions. Now let's talk about reducing fractions. There's 2 ways to reduce fractions. So expanding is like multiplying. Reducing is a lot like dividing. So up here we multiplied the top and bottom number by the same number. Down here we're going to divide the top and bottom by the same number. So let's start with 36 over 72. We'll go to orange. Say we have 36 over 72 and I need to divide. What I'm going to do is I'm going to divide both numbers by something that they can both be divided by. This is where divisibility rules come in handy again, right? So what number can go into both 36 and 72? Let's zoom in a little more, clean up some focus. Whoops, that wasn't better. There we go. Well, you can see they're both even numbers, so they'll both be divided by 2. 36 divided by 2. Let's do a quick algorithm over here. 16, and then 2 goes in 16 8 times. 0. Okay, 18. So 36 divided by 2 is 18. All right, and then I'm going to go ahead and cheat on, well, not cheat on this one, but I know for a fact, because I've memorized it, that 72 divided by 2 is equal to 36. Okay, so I divided by 2, and I now have 18 over 36. Well, am I done reducing? No, because I see both of these numbers are still even, which means they can both be divided by 2. So I'm going to divide again. Maybe I'll go to green this time. So I'll divide by 2 one more time. Do I have to divide by 2 every time? No. This just happens to be the number that I noticed. So let's see here. 18 divided by 2. Ooh, that actually equals 9. And then 36 divided by 2 I just found out is 18. That's 9 over 18. Now here I see something. I see 9 and 18. I know 9 goes into 9, and I know 9 goes into 18. So now I can just divide by 9. So if I divide the top by 9 and the bottom by 9, I end up with 1 and 2. Yeah, 9 divided by 9 is 1, 18 divided by 9 is 2. Can this be reduced? No. Once I get to the point where I can no longer reduce, or I can no longer divide this number, I have my answer. So 36 over 72 reduced to lowest terms is actually 1/2. All right. Now, that was a lot of work. I had to divide 1, 2, 3. I had to divide 3 times to get my answer. Now let's talk about dividing using the greatest common factor. So here I've got a similar problem. I have 18 over 24. What if I could find a way to only divide once? Well, I can if I use greatest common factor. So we'll quickly find the greatest common factor of 18 and 24. So let's take 18. I'm going to do a factor tree. I've got 2, 9. 9 is 3 and 3. All right, so 18 is going to be 2.3.3. And then we'll take 24. 24, well, we'll do a tower for 24. We've got 2, 12, 3, 4, 2, and 2. So I've got 1, 2, 3, 2, 2, 2, 2, and 3. 2, 2, 2, 3. Now I look for numbers with pairs. That has a pair. That has a pair, and the rest of these are loners. So the greatest common factor is going to be 2 times 3, or 6. Great, I found the greatest common factor. And you're thinking, Mr. Claiborne, how in the world does that help us? Well, once I find the greatest common factor, I know exactly what number to divide by. So let's take 18 over 24. We're going to divide each side, or well, each half by the number 6, and we will see that by only dividing once, we will have a completely reduced fraction. So 18 divided by 6, so that equals 3. 24 divided by 6 is 4. So now I have the fraction 3/4, which is completely reduced. And I only had to divide once that time. So if you get very good at finding the greatest common factor, which you're going to, you can only divide, you can save yourself some time, divide once instead of dividing 1, 2, 3 times, or sometimes 4, 5, 6, depending on how long it takes you. All right, well, that's it for this lesson. If you have any questions, let me know on the website, and I'll see you in the next video.